Hey everyone, it's Tara. If you've seen my channel, you know I'm not really like a pro YouTuber, but I've been wanting to practice making some videos again. And I have the perfect opportunity because I just got myself a new toy and I'm very excited about it. I subscribed to the new Attacking and Defending AWS learning path that TryHackMe put out. As some of you might know, I'm very obsessed with AWS. I used to work there and I've been working in cloud and cloud security adjacent roles for almost 3 years now. I also used to use TryHackMe a lot back when I was studying cybersecurity in school. I'm definitely rusty as a TryHackMe player now, but I've been wanting to get back into it anyway. So all these factors have come together perfectly. I've got my subscription to the new learning path. As I play through it, I'm going to try to make some video walkthroughs just for fun and to try and get as much as possible out of the experience. In this first video, I'm going to give a quick overview of the Attacking and Defending AWS learning path, the different rooms, some of the topics they cover. Then I'm going to play through the first room. So I hope you enjoy it and let's see how it goes. Here I am on TryHackMe. Definitely make sure and clock that nice 0-day streak I've got going on up in the corner if you want to see what a cool little hacker I am. But you know what? Now it's day one, so that's exciting. Here's the Attacking and Defending AWS learning path. I believe that TryHackMe originally rolled this learning path out for businesses, and then they fairly recently released it for individual subscribers to play through as well. It is an extra subscription on top of the TryHackMe subscription, and it's significantly more expensive than regular TryHackMe, which I also subscribe to. So maybe if you're thinking about it, this video will kind of give you some insight onto if you want to take the plunge. Here is the overview of what all the different rooms contain. So you see we've got some different learning objectives in this learning path. We are going to identify, enumerate, and exploit overly permissive IAM users, roles, and policies. We're going to be exploring serverless infrastructure and common attack vectors present within serverless. And then we're going to learn how to exploit weaknesses in the common AWS services, including S3, EC2, VPCs, and more. Our prerequisites, TryHackMe says we need to have a basic understanding of cloud and AWS environments and a broad understanding of different areas of cybersecurity to complete this pathway. Here's the juicy stuff. So here's the actual learning path. Looks like we've got it divided into 5 different areas. And then within each of these areas, there are different rooms. So we've got 2 introduction to AWS rooms, Cloud101 and AWS basic concepts, introduction to IAM, which is identity and access management. There'll probably be a lot here. We're going to be talking about all the different fundamentals of IAM, principles, permissions, resource policies, SCPs, the quest for least privilege. That sounds very exciting. STS credentials, etc. Attacking and defending core services. So let's see what services we're going to be working with. We've got S3 buckets, EC2, VPC, which is like networking, and then the AWS encryption services. So KMS, which is keys, and then ACM, which is the certificate manager. Attacking and defending serverless, which I'm especially excited about. So we've got Lambda, Lambda data exfiltration, and then a AWS API gateway room, which I'm really excited about and hope I'll learn some new stuff there. Lastly, we've got IAM privilege escalation. So I wonder maybe we're going to kind of use some of what we learned in these earlier rooms to really get in here and do some privilege escalation. Put your understanding of IAM to practice by covering key concepts required to enumerate, exploit, and persist across IAM. Sounds very fun. It does say somewhere about how many hours of content TryHackMe thinks this is. I suppose I could probably use this learning scheduler and work backwards and figure it out, but I'm not going to do that. So I'll try to remember where it says that and I'll put a link below this video as well. But overall, it looks like good stuff. I think it'll be fun and interesting. So let's get started. This is the AWS Cloud 101 room. So this is the first room in the learning path. Description says an introduction to AWS and how cloud has changed computing. For task 1, we have an introduction where we're going to, I suspect, read the learning objectives. We've got 4 learning objectives here. We're going to learn about how current cloud capabilities evolved from humble beginnings at AWS and other early internet companies, why cloud technologies have changed how individuals and corporations interact with IT, how business benefits have helped drive cloud adoption, and free resources and documentation that AWS has created for the public. This reminds me of my onboarding when I worked there. So this is going to help us get familiar with AWS, even if you haven't used it before. This is your introduction, and we're going to understand the story, the narrative, the origin story of how cloud got to where it is. So we can just say, Completed. We read the learning objectives, no answer here, and we're ready to move to task 2. Task 2 is called Cloud Enters the Scene. Looks like this room is mostly going to be like reading and answering questions, which we can do. The first part here is discussion of the on-premise model. So this is talking about how since the 1970s, organizations had been hosting their own IT infrastructure. And then in the 1990s, there was the dot-com boom, and businesses got more reliant on internet-connected services. Data centers got a lot bigger, and then third-party solutions popped up to host data centers for different businesses. Then came the cloud. I like those quotation marks. Says here, at first, the cloud often just meant hosting servers in somebody else's data center rather than managing your own servers, which is still what a lot of people think of when you think of the cloud. I like this line here. While perceptions persisted for some time that the cloud was just someone else's computer, this room is designed to cover some of the unique characteristics of cloud providers and specifically AWS. That actually cracks me up because one time I was just walking through Boulder, which is near where I'm from. And of course, there's a lot of techie people there. And this was a while ago before I ever went back to school for IT. So I didn't know very much about the cloud yet. I hadn't been assimilated into the cult yet. But I saw this woman wearing this shirt in downtown Boulder, and the shirt said, "The cloud is just somebody else's computer." And that stuck with me for so long. Like I saw that shirt and I was like, oh, I feel like I understand what the cloud is now. So that's hilarious. TryHackMe is challenging me on my perception. I got to think beyond that. The cloud is more than just somebody else's computer. Noted. Okay, so now we have our first question to answer here. What decade did companies start having widespread reliance on internet connected services? So the answer here is 1990s, where they were talking about the dot-com boom. Whoop, whoop. Our answer is correct. Moving on to task 3. Task 3 is called more scalable. So let's see. We're starting with growing demands. Starting in the late 1990s, websites could not handle traffic coming their way from the ever-growing World Wide Web. The quotes have already made a return. And as the 2000s started, a number of technologies came along on the scene to address these needs. First, there was content delivery networks that would serve static content on behalf of a website. Then along came AWS EC2, a virtual machine service that would allow customers to deploy additional servers on demand. So if you didn't know, AWS EC2 is like the basic compute service of AWS. I think AWS EC2 Compute is still the most used AWS service. Anyway, so we scroll down and we talk about an evolving approach. We got a diagram and everything. All right, so the evolving approach section is talking a lot about auto scaling and how AWS released the official auto scaling feature for EC2 in 2009. And what auto scaling is all about is being able to scale your infrastructure, so your servers, your storage, maybe your database, programmatically in response to different conditions. So the auto part typically means without a human having to go in and add another server, your infrastructure can respond dynamically based on different conditions, different metrics, different triggers. And that's what this section is talking about, a little bit about the history of EC2 and auto scaling. And then this part is pretty interesting, kind of talking about how auto scaling started with EC2, but now AWS has a lot of services that further enable scalability. And that's where we start getting into discussion of cloud native architecture, which is where an application was architected, built, developed, knowing it was going to be run in the cloud and designed to really take advantage of everything the cloud can do as compared to a typical on-prem environment. We've got a very nice diagram here. I absolutely love a good diagram. I like how we have like this green alien aesthetic going on here to make us feel really techy. What's going on in this diagram is we have different types of applications, containerized or non-containerized. It's okay if you don't know what that means. And they run on different compute services within AWS. Those compute services take advantage of auto scaling to maintain application availability and define how to scale to meet demand when demand to your application fluctuates. Those services take advantage of auto scaling to do a bunch of different things. Scale your resources up and down based on demand to your application. Do proactive health checks to identify and replace if one of your servers is unhealthy. And I don't really get this part, why this is kind of like an output, but basically describing there's different types of auto scaling groups. So EC2 instances have auto scaling groups. ECS containers have auto scaling groups. And EKS have managed node group. I don't know very much about Kubernetes, so I won't sound intelligent if I try and talk about that. This sentence really seems to sum up what the diagram is about. Auto scaling allows scaling any type of application, containerized or non-containerized, and maintains application availability to meet customer demands. Here's the question for task 3. Was EC2 auto scaling the first auto scaling service in AWS, yay or nay? Well, Based on what they described earlier, yay, indeed, it was the first auto scaling service, and now more services have built on it. So, oh no. No, I already got one wrong. It only took me 3 tasks. All right, well, maybe let's see if we can say nay, and there'll be an explanation of why we were wrong. Whoop whoop, our answer is correct. Was EC2 autoscaling the first autoscaling service in AWS? Okay, so we don't get an explanation here. Let's scroll back up and see what they said about this. Says here, while third parties initially created autoscaling services, AWS released the official autoscaling feature for EC2 in 2009. So that makes me think the answer is yay. I'm going to have to go back and figure out why that is the wrong answer because now I'm confused. Okay, so I'm anal retentive about stuff like this. I just paused the recording to go do some more research to try and figure out why the answer to this question is nay because I don't really get it. I read another walkthrough. I watched Tyler Ramsey's great walkthrough of this room, and he had the exact same thought process I did. So that made me feel a lot better. So let's just move on. But if anyone knows why nay is the answer to this question, please let me know. Please comment below because I'm still not getting that one. But I won't get stuck on it. Let's move on to task 4. All right, I'm jumping back in time a little bit because I thought about this a little bit more. This question, was EC2 autoscaling the first autoscaling service in AWS? I think the reason why the answer is nay is because they're mentioning up here AWS released the official autoscaling feature for EC2 in 2009. However, third parties initially created autoscaling services. So the reason why my answer was EC2 autoscaling, the first autoscaling service in AWS, was wrong was because that was the first official AWS autoscaling solution. However, there were third party autoscaling solutions for EC2 that beat AWS and were in place. Okay, I feel a lot better now that I've figured it out, and I think that makes a lot of sense. So now my mental peace is restored, and hopefully we can all move on with our lives. Task 4 is called more reliable. So we had more scalable in task 3. Now we have more reliable. I wonder if these kind of go along with the AWS well-architected framework, because this is all the same concepts. So more reliable looks like we've got discussion of legacy on-premise pattern. Legacy on-premise pattern is discussing how prior to the cloud, failover capabilities for data centers were manual and highly customized for the technology stack of a particular organization. This often took the form of a primary and then a backup data center that were geographically separated from each other. And this was very expensive for companies and took a lot of maintenance. It was hard to gracefully fail over between the two physical data centers. And there was always that risk of a prolonged outage, which is not good for your business objectives. Just basically describing the way it was before cloud, how it was expensive, how it was annoying, basically how it sucked. Then we're contrasting the legacy on-premise patterns to the cloud patterns, talking about how AWS and other hyperscale cloud providers, meaning I'm sure like GCP, Azure, the big cloud providers out there, have a big advantage in reliability because they can operate at such a larger scale rather than one company with a data center and then a backup data center. AWS is a huge company. They have so many data centers. They can run them a lot more cheaply. They have a lot more options for failover. They can get a lot of data and insights for optimizing their systems. There are many, many things that AWS and the other big cloud providers can do that a smaller company could not do with 1, 2, 3 data centers. Now we're going to get into some of the very fundamental concepts about AWS, which is the AWS global footprint. Says here, at the time of writing, AWS claims to have 99 availability zones in over 31 regions. I wonder, so we can check on the AWS website what the current number is. I wonder if that's what this is a link to. Perfect. AWS global infrastructure. So now there are 33 launched regions and 105 availability zones. So let's compare that. Might give us kind of some insight into how long ago this was written. So 2 new regions and 6 new availability zones since this content was written. Let's let's unpack that. Let's unpack what that means. Region. Region is the top level construct here. A region is made up of one or more availability zones. So that's really important to remember. If anyone's watching, you're trying to study for like maybe certified cloud practitioner or anything, you need to make sure you know this. An availability zone is part of a region. So a region always has at least one availability zone, almost always more, I assume. And then within availability zones are the data centers themselves. So an availability zone is one or more discrete data center with redundant power, networking, and connectivity in an AWS region. Data centers are separated within availability zones, and availability zones are separated within regions. And then we've got this diagram of an example region. So in this one example region, we've got availability zone A, availability zone B, and availability zone C. And then in each of these availability zones would be at least one data center, probably more. We're talking about reliability in this room here, right? And so when you just really think about it, it makes sense because there's this redundancy throughout, right? Data centers are redundant within an availability zone. Availability zones are redundant within a region. So if one data center was to get taken out or lose power, as the example they give here, or even if a whole availability zone was to get taken out by a natural disaster or something like that, there's that other data center or that other availability zone within the AWS infrastructure where automatic failover can occur without you as the customer even having to worry about it. Definitely, if you're trying to learn AWS, come into this task and read through it thoroughly. This is a lot of good information. I'm just kind of skimming over it. Talks about naming conventions. That'll be very useful just even when you're working in the console, giving some examples. Now, here's the question it's asked us. How close together in miles should an availability zone's data centers be? I think the answer to this is 60 miles. I'm sure it probably already just said this up here. Let's see what it said. Yes. Data centers that make up an availability zone will all be located within 60 miles of each other in that given region. So they don't release data about how many exact data centers there are or exactly where they are or how far apart they are. But this is what you'll always hear is that they're within 60 miles of each other within an availability zone. Wonderful. No surprises there. So that's correct. We'll close that task out and move on to task 5. Task 5 is called distributed around the world and in space question mark. Let's see what this is all about. Looks like this section discusses some of the different implications of what it means when you have that global infrastructure you're operating in all these different areas around the world and I guess in space as well. So data sovereignty and latency. The data sovereignty section is pretty interesting. This is just talking about how different countries, different areas of the world have different laws around data and data protection. So AWS has to build their services to be able to be in all these different regions where customers have different legal requirements about how they have to handle their data, where they can store their data, a bunch of things like that. This section also mentions AWS hosts regions on every continent except Antarctica, so that's pretty interesting, and in many key locations with data sovereignty requirements. It mentions how AWS China is on a separate partition of the cloud, and what separate partition means is that basically there's like a hard boundary between the China region and other AWS regions. It's completely separate. Whereas other commercial regions like US East 1, the European regions, any other region you've probably heard about, they are more interconnected. AWS also has separate partitions built for different government use cases as well. So that's what the data sovereignty part is all about, is that data is handled differently. There are different requirements around different types of data in different locations, and the cloud has to be prepared to deal with all of that. And then latency is talking about how beyond thinking about data sovereignty, when you're this spread out around the globe, you also have to think about how quickly data can travel around. So if you're new to all this, you can think of latency as basically how long something takes. When you make a request to something, how long does it take to get a response? As you build an application, one of the big advantages of the cloud is that the cloud has these points of presence all around the world. So even if you're a small company and you operate in one country or one region, you can use the cloud to replicate your IT infrastructure all around the world, to replicate your data all around the world. And that means your customers deal with much less latency than if you were just serving data out of one data center located wherever you're at. This section describes it in much more detail, so hopefully you all have the opportunity to read it. And now we get to these questions. What continent has no AWS region? So they told us that was Antarctica. Let's see if I can spell it. Nope, I can't spell it. Let's copy and paste it. So embarrassing. Let's try again. Okay. And then what country has its own AWS partition? Hopefully I can spell this at least. So that is China. Awesome. So that's task 5 sorted. Let's move on to task 6. Task 6 is called operational expense versus capital expense. Sometimes you'll hear people say OpEx versus CapEx if you want to abbreviate that and sound cool. This is talking about, I suppose, the business implications of cloud and how that has been part of cloud adoption. Let's see what this is all about. It says, while this course is focused on security associated with AWS, it's important to understand the business value of cloud versus on-premise data centers. After all, Love this. After all, companies only use technology so they can make money. We want to understand the business value of the cloud is related to the notion of CapEx versus OpEx. So they give you the abbreviations here as well. So it's not breaking news. In business, a capital expense is a major purchase of goods or services intended to be used by a company over a long period of time. In contrast, operating expenses are expenses incurred as part of day to day operations. In the past, organizations were known to pay in excess of $1,000 per square foot for data center build out and configuration. Using that pricing, a 1,000 square foot data center would cost about 1 million US dollars. With the expensive nature of data centers, cloud providers saw an opportunity to create a different approach. Essentially, every wasted compute cycle represents poor investment dollars spent. The inefficiency was dramatic when calculated across industries. Cloud allows a pay as you go and reserved capacity model to better manage IT expenses relative to the organization's IT needs. Basically, one of the points here is instead of building a huge data center, which is a CapEx, the cloud allows you to pay for computing and IT resources as you go, which is a OpEx, like a utility. And then the most important part, probably any cloud person would tell you, is that most cloud services are pay as you go. So if you have a whole data center full of servers and you have times of high demand, like Black Friday is the classic example, and maybe all your servers are whirring and you're using all of them at full capacity. But then you have times of low demand, like January, you're paying a bunch of money for server capacity that you're not using. Whereas in the cloud, because of that auto scaling we already talked about, you could scale way up for Black Friday. And then as soon as you don't need that capacity anymore, you can scale your servers down and pay only for what you're using. And that is how the cloud has ended up saving companies a lot of money. And that's been a huge driver of adoption. To put it simply, we could go a lot farther into it. Finally, only spending money on assets that are currently in use has the advantage of enhancing operational agility. So that's another huge piece of it. It's not just the saving money part, it's also the ability to pivot, to make changes to your infrastructure a lot more quickly. At AWS, we always used to say, fail fast. You can try something, you can learn from it rather than having to build a whole new data center or whatever. You can just simply change what you've got deployed in the cloud. It's a lot more flexible and agile. Anyway, let's see what the question is here. Is a major purchase intended to be used by a business over a long period of time a capital expense or an operating expense? Well, I believe that is the definition of a capital expense. Let's see how we do. Correct. All right. So that's me heavily glossing over the idea of OpEx versus CapEx. Let's move on to task 7. Task 7 is called API mandate and the two pizza team. So, seeing the two pizza team thing, I think we're about to get into a little bit of AWS lore here. So, the API mandate, this says even prior to the formation of AWS, the CEO of Amazon, Jeff Bezos, well, he was the CEO of Amazon when this was written, as you probably know, he's not anymore. Anyway, Jeff Bezos issued a mandate across Amazon that internal teams would be required to make their data accessible to all other teams via a service interface or an API. And an API stands for Application Programming Interface. As the legend goes, the specific mandate stated the following: all teams will henceforth expose their data and functionality through service interfaces. Teams must communicate with each other through these interfaces. There will be no other form of inter-process communication allowed. No direct linking, no direct reads of other teams' data stores, no shared memory model, no backdoors whatsoever. The only communication allowed is via service interface calls over the network. It doesn't matter what technology they use, HTTP, Corpa, PubSub, custom protocols, doesn't matter. All service interfaces, without exception, must be designed from the ground up to be externalizable. That is to say, the team must plan and design to be able to expose the interface to developers in the outside world. No exceptions. Anyone who doesn't do this will be fired. Thank you. Have a nice day. And this is attributed to Jeff Bezos in 2002. So this is saying Jeff Bezos said from the very beginning, as these different teams in AWS were building out their systems and designing their systems, they had to design them in such a way that external entities could interact with them via like a traditional API. Then it says, it turned out that creating standardized APIs to interact with AWS services and resources is the key capability to unlock automation for AWS customers. If you're new to the cloud, one thing to understand is that whenever you interact with a cloud provider, so be that via the console, clicking around, doing ClickOps, be that interacting programmatically from the command line or using an SDK, you're simply making calls to the cloud provider API to do actions in the cloud. That's what this is getting at, is that from the beginning, these teams within Amazon were taught to build their systems in such a way that external entities could easily interact with them via something like an API call. Oh, okay. So this just kind of says the same thing except better summarized. Any customers who interact with AWS services are ultimately interacting with service APIs, in many cases, the very same APIs that AWS employees use. And sounds like Jeff Bezos envisioned that from a very long time ago before the cloud was even a thing. He designed with that vision in mind and told people if they didn't get with it, they were going to get fired. And then the two pizza team thing, I have heard this before. This is about a philosophy Jeff Bezos had within AWS where he believed teams should stay fairly small. So he believed no team within Amazon and AWS should get so big that they couldn't be fed with two pizzas for a team meal. And this philosophy has contributed to a culture in AWS, or at least used to be this culture, where service teams and individual teams kind of operate like their own startup. So different service teams thinking about the service they build and maintain as being like their own little individual product. A couple other things it says here. So the reason Bezos had this philosophy was he believed smaller teams better foster collaboration. And then it says, while it is true that this collaboration likely led to much of the innovation we appreciate from AWS today, it also had another effect. AWS has over 300 services, and each of these services is run by a different team, like we talked about. When developing APIs, and APIs are what you interact with all the time as the customer, API naming conventions do not have maybe the kind of consistency that we would like across different AWS services. So this is interesting because this is the first part of this content so far where they're taking a little bit of a dig here. But they're saying, unfortunately, with the various AWS teams, there's a lot of variety in the naming convention of AWS service APIs. When using services that may have similar capabilities, end users can't rely on those APIs being consistently named. So I wonder if whoever wrote this has been burned here before. But it is a good point when you're interacting with things, especially programmatically, the naming conventions are really important. Oh, well, once again, I jumped the gun. It says, with the need to be precise with programming grammar, these inconsistencies can leave developers frustrated and extensive digging through service documentation. All right. And then it says, who announced the API mandate at AWS? That's our question. So the answer there is Jeff Bezos. If I can. Oh my gosh. I can't type 4 letters. Okay. Submit. Whoop, whoop. That is the correct answer. Well done, us. Moving on to task 8. Task 8 is called free open source capabilities. And there's 2 sections, built-in advantage and service tools. Built-in advantage starts with when you use AWS, you have access to a large number of services pre-configured to get you up and running quickly. Whether you need a website, a database, or a CI/CD pipeline, AWS has capabilities ready to go for you. So that's kind of talking about like one of the things about the cloud is what's called managed services. And managed services abstract away sometimes some of the work for you. So you could just have an out-of-box solution. You click, you deploy, you're ready to go rather than having to build something yourself. And then beyond these services themselves, AWS has made large contributions to the open source software space. These contributions include a wide variety of tools to enable AWS services along with pre-built solutions to general business IT problems. Then this next paragraph is giving some examples of those tools that exist to help you use AWS essentially. The first example they use is CloudFormation, which is an infrastructure as code tool, which I'm absolutely obsessed with. I'm sure eventually I'll have some videos about CloudFormation. But CloudFormation allows you to deploy your cloud infrastructure using predefined YAML or JSON. Infrastructure as code is indicating you run code, and that's what spins up your infrastructure for you. And beyond providing the service itself, referring to CloudFormation, AWS provides reference implementations and sample templates for various AWS services. Then we read about how, in addition to providing CloudFormation, which is, I guess, is considered an open source tool based on the section heading here, beyond providing CloudFormation, AWS also provides different open source templates and reference implementations you can use to take CloudFormation and work with AWS services. Then this is like such a specific example, but one really specific example here is that there's a GitHub repository full of AWS samples, one of which is a fully functional airline booking application. So we can go quickly look over here and we have this GitHub repository full of open source AWS samples. I think the point here is just that AWS has open source tooling that they've contributed and built. And then service tools, one notable type of open source software offered by AWS is ecosystem tools. So this is more examples of free tools that you can use to work with AWS. So they give an example, things like AWS Data Wrangler, AWS Shell, which is the integrated AWS CLI, and then AWS Lambda Power Tools Python, which seems like is a library that enhances AWS Lambda functions functionality, As these tools and capabilities are not widely advertised, AWS customers might not be familiar with many or all of the capabilities. However, as an AWS user, you should research and be aware of AWS services and example code before you try and go wild developing your own custom stuff. I guess that's the moral of the story is do your research as you're learning the cloud and learn about the open source tooling that's in place to help you build faster, which is a good message. And the question for task 8, what is AWS native infrastructure as code tool? I think that might be missing a word, but I think the answer is uh, the AWS native infrastructure as code tool that was mentioned in this section is CloudFormation, one of my loves of my lives. Excellent. So CloudFormation is the correct answer. This is probably the easiest time I've ever had in my life with anything to do with CloudFormation. And we can move on to task 9. Task 9 is called serverless and other low code solutions, which is kind of interesting because I wouldn't really describe serverless as a low code solution. So I think this title is a little bit of a misnomer, but I guess we're going to discuss both topics. We've got 2 sections in here, genesis of serverless and then low code / no code solutions. The genesis of serverless section is talking about some of the early AWS services that kind of paved the way for the serverless architecture that a lot of people use today. So talking about how S3, which stands for Simple Storage Service, DynamoDB, which is a database service, and then SNS, Simple Notification Service, were some of the first AWS service offerings where customers didn't have to put any effort into the configuration of underlying resources or ongoing maintenance for the resources that support these services. If you don't know what serverless is, you've never heard of it before, a serverless architecture is a way of building applications and services without ever having to manage any of the underlying IT infrastructure. So your application, for example, still runs on IT infrastructure. It runs on servers. It relies on hardware in a data center somewhere, but you don't have to worry about that. All of that underlying infrastructure is abstracted away from you. In this case, it's managed by AWS. And you, as the customer, don't spend any time on configuration or ongoing maintenance. That's a very simplified explanation, but one of the really important things, and this is part of what's mentioned here to understand about serverless, is typically when you're using serverless services in AWS to build a serverless application, you do not pay any cost for your application when the application is idle. So in a traditional model where you're running your application on a server that you manage, you are paying at least something to have that server up and running all the time. Serverless services, typically the model is infrastructure is spun up ad hoc for you only when your application needs to do something, only when it needs to respond to a request or an event trigger has gone off and now your application needs to do something and you're going to pay for the resources that the application uses to do the job it needs to do. And then once the application is idle again, you're not paying for anything. You don't need to worry about patching the server, nothing. AWS does all of that for you. You simply worry about whatever the functionality of your application is, whatever the job it's supposed to be doing is. You don't worry about any of the underlying infrastructure. And that was that was a big change. It was a huge deal when serverless started becoming a thing. And in a lot of use cases, it's very cost effective because you don't have a situation where all your servers are running at the same cost to you, no matter how much traffic is coming in. Then it says here, these benefits were immediately clear. And I'm a big serverless fan, so I would agree with that. And then, yeah, it just goes on to elaborate on how there are now a vast range of AWS services and tools to build using a serverless architecture. And then this is a nice sentence. For a developer, there are few ways to go from an initial idea to a functional, scalable, and publicly accessible application faster than using AWS serverless capabilities. Isn't that nice? And if this is the first time you're ever hearing these terms, this is your first exposure to the idea of serverless and serverless architecture patterns. I know one of the modules in this learning path is serverless technologies, specifically Lambda and API Gateway, I think we just saw. So it'll make more sense, I think, when we're knee deep in it. So don't worry. And then that was section 1. Section 2, low code and no code solutions. The traditional, whenever I see low code or no code, like what I immediately think of is drag and drop. So a low code or no code solution abstracts away some of the more technical details of implementing something, and in this case, implementing something in the cloud, and allows somebody who maybe doesn't have a ton of programming skills or some sort of certain technical skill to point and click or interact in some other user-friendly way, and then all the technical stuff is implemented on the back end. So that's what I always envision is like when I see no code, I'm thinking some drag and drop interface where you're dragging and dropping, you're building something, and then the program constructs for you all the code. It's all abstracted away from you. So let's see what examples we have here. We have AWS Honeycode is an example of a pure no-code solution offering a drag and drop interface for building web applications and static websites. I've actually never used Honeycode. Let's see what this is about. Oh, okay. Amazon Honeycode, which is in beta. Oh, oh, and then it says effective February 29th. They're going to be discontinuing it. So don't get attached to Amazon Honeycode, but apparently that was a good example of a no-code solution where you did the drag and drop to build static websites. And then the other example here is AWS Amplify, which I have used before. And Amplify, I would say, is more of an example of a low-code solution. You are going to need to have some technical skills, some technical know-how, but Amplify abstracts away for you some of the technical details of building out a backend for an application. So it helps you build out your application backend, things like your database and stuff, using AWS services, but without you having to do all the implementation yourself. That's what Amplify is about, if I recall correctly. So Honeycode was their example of no code. Amplify was their example of a low code solution. The point being some of the technical implementation is abstracted away. Then the conclusion, while still in the early stages, AWS and other cloud providers are working to create software development workflows that don't inherently require programming skills. I think this is so true. So I was at reInvent, which is like the big AWS annual convention this year. It's my first time I ever got to go. It was really fun. And that was one thing myself and some of my colleagues that I was there with really commented on was it seems like no code and low code is more popular than ever. It seems like AWS is coming up with a ton of innovations in this area. So I'm sure there will be more to come. Now, here is the question for task 9. Does serverless cost more or less when running idle than traditional servers? So the answer here is less. And in fact, serverless often costs nothing when running idle, which is lovely. So let's hit submit. Whoop, whoop. That is task 9 complete. And now we can move on to the final task, which is task 10. Okay, so now we're here on task 10, which is the summary task. During this room, you have learned some history about cloud technology and the basic benefits of using the cloud. We should now understand how technology limitations in the 90s and 2000s drove the development of cloud technologies, how capabilities associated with reliability and scalability are hallmarks of cloud service providers, how companies may see cost and IT agility benefits from using the cloud, how an API first approach was powerful but also had drawbacks, how AWS provides various services, capabilities, code, and documentation for free. So this is all pretty glowing. This background knowledge should serve as helpful context as you further explore cloud technologies and our other AWS rooms. Let's have a small test. Click the View Site button at the top of this task. So I already clicked it, View Site, and that's what opened this, to launch the static site in split view. What is the flag after completing the exercise? Okay, awesome. So now we're getting into more like a traditional like CTF capture the flag type of exercise. So here's our instructions. You have been tasked to develop a social media interaction website where users can communicate with each other with features more or less like those on Twitter or Facebook. You're tasked to get input from all the teams, prepare a feasibility report, and present it to the CEO. Ooh. You will visit each department and you will be asking certain questions. We will only get 30 seconds to answer each question. In case of running out of time, you get a penalty and your game will be over after 3 penalties. Okay, we're not messing around. Okay. All right. So I got my drink ready before I hit start. It's cloud themed and everything. Let's see what this game is all about. Let's go. Click on the department to visit it. Okay. So let's see. We've got all right. So we got software engineering, CEO, DevOps, finance. I see. So maybe we're going to kind of talk about cloud in the way that motivates each of these different populations. Let's start with DevOps. It's kind of hard to click on. Let me keep trying. All right. The website will be accessible from all over the world. Shall we deploy all the infrastructure on our premises or go for cloud services? Okay, so this is that kind of like, I think we talked about this in the latency section. If we're going to be all around the world, it'll be easier to replicate in the cloud. What is the most practical reason for selecting the cloud services model? Lesser latency rate for website users and easy scalability as the user base grows. On-prem infrastructure cannot host a website. Well, websites existed before the cloud. In fact, they launched the cloud via a website, I'm sure. So lesser latency rate is what we will go for. All right, so seems like we convinced DevOps. Let's go see what the software engineers want to hear about. The software engineering team mentioned that the complete team is housed in California, therefore they need a high availability server in that region. If AWS is selected as cloud service provider, what would be the naming convention for that region? Oh, okay. I didn't really dive into these in the video, but what they're looking for here is US, the naming convention for the region. US East 1, if you're familiar, or US East 2, or US West 1, or US West 2. California would be US West 1, I guess. Which of the following service will be used? Which of the following services will be used to route traffic based on users' geolocation? EC2, so that's compute. No. The traffic will get routed to compute services, probably. RDS is databases, so we're going to go with Route 53. In line with Jeff Bezos' model at Amazon, each developer of our software team will expose the data to other members through a service interface called, let's go with API, which stands for Application Programming Interface. All right, now over to finance. I'm saving the CEO for last just in case, like the final boss type of situation. The payment will be made to cloud service providers on a pay as you go model, and infrastructure will be expanded per the need. Which of the following expenses is optimally used in this case? So, pay as you go and the infrastructure. So, I mean, they're looking for OPEX. So, I'm going to go with operational. Oh, no. Okay. That was wrong. The payment will be made to cloud service providers on a pay as you go model, and the infrastructure will be expanded per the needs. Which of the following expenses is optimally used in this case? See, this, I'm not a finance person, but I guess operational was wrong. So let's go with optional. All right, that was it. And then over to the CEO. Let's see how it goes. Feasibility report. Okay, so this is summarizing what we told the DevOps people, what we told the software engineer people, and then finance. Which of the following, I still don't really get the way that question is phrased, but I have faith that it's right and I was wrong. Let's hit next. And the flag. So we got our feasibility report. We convinced the CEO. So now we get our TryHackMe flag. Let's paste, submit. And awesome. We finished our first room. Yay. This is so exciting. It's been so long since I've done a TryHackMe room. So I'm on a roll. I think I'm just going to continue on to next room AWS basic concepts, but I will make that into a separate video. So hopefully if you watched this one, you enjoyed it. Cloud101 was a very nice overview to the basics of cloud computing if you're not familiar. Thank you for watching, and perhaps I will see you in this next AWS basic concepts room.